AUD's schematic functions, expand, expand edit, and collapse, provide a powerful way to create schematic representations of your designs. In this video, I'll cover 4 ways of configuring these functions, including the basic values available under AUD options, the schematic rules, ways to add ribbon commands using Lisp command wrappers, and ideas for powerful functions created using Lisp or ARX. Let's start by using the most basic configuration values. These can be found under AUD options within the General Layout section. If I scroll down, you can see 6 items under schematic offset. These two, default offset line and default offset point, are used when drawing new components that are offset from other CAD or AUD objects. These don't apply to the schematic functions, but these remaining 4 items do. They include the default expand interval. When you perform an expand function, if you don't click to specify a distance, this is the distance that will be used for the highest priority lines, and this is the spacing that will be used between lines. The expand and snap mode value is used when you run the AUD expand or the AUD expand edit command. If set to true, then the expanded lines will snap to the interval and will snap from one offset value to another when you're using the expand edit command. When set to true, schematic arcs for connectivity will generate arcs when a cable or conductor bypasses an inline object to which it is not connected. Finally, schematic expand innermost line, when set to true, will enable all conductors and ducts to expand away from the segment. Setting this to false will allow one of the conductors or ducts to remain aligned with the segment. Here's an example of these settings in action. For this demo, the default interval is set to 3, and the other 3 parameters are all set to false. When I first do an AUD expand, I'll press enter when the cursor distance shows 2.52. Here's the result. You can see that only 2 of the conductors expanded because expand innermost line is false. When I measure the distance between them, it's 2.52. The 3-foot interval snap is not used. And you can also see there are no arcs. Finally, when I use AUD expand edit, I can move the conductor to any interval because the snap mode is false. And here's what you get with some different settings. In this case, the default interval is still 3, but arcs are turned on and the expand and snap mode is set to true. When I run AUD expand, even though I choose a distance of 3.5 with the cursor, when I press enter, the offset snap uses the value of 3. Arcs are drawn around the handhold. And when I use AUD expand edit, the conductors snap 3 feet at a time from one interval to another. So to review, with AUD options, you can control the spacing between expanded lines, determine if the interval spacing is active, control the appearance of arcs, and determine if the innermost line is expanded. Now let's explore what can be done with the AUD rules. I'll use a somewhat artificial demo to illustrate how these rules can work. On the screen you see a single trench. When I select it, you can see that it contains 4 cables in ducts, a feeder, a primary cable, a secondary cable, and a service cable. Now I'll open the AUD Rules Editor. Near the bottom is a relatively new section for schematic rules with 3 sections: expand interval, expand priority, and is included. In this video, I'll explore the first 2 sections. I'm going to create a rule under expand priority for conductors. I'll use the choose value where function. The conductor attribute I'll evaluate is the conductor type, and I'll create 4 choices in the rule. If it's a feeder conductor, priority will be 1, primary will be priority 2, secondary will be priority 3, and service will be priority 4. What I'm doing here is defining the priority for being closer to the segment when the expansion occurs, with priority 1 being the closest. Now this rule's in place, and I'll try using AUD expand with my trench sample. Here's the result, and if I select on each of the expanded cables, you can indeed see that the feeder is closest to the trench line and the service is furthest away. I'll now use AUD collapse, but before selecting the cables, I'm going to use the reset function. Remember that once expand occurs, the expanded geometry is sticky. The order that conductors appear is part of that stickiness. The reset option will ensure that AUD will forget these values as my demo proceeds. Back in the rule editor, I'm now just going to quickly modify my rule by changing the priorities. Now, feeder has the highest number and service cables the lowest number. I'll save these changes and perform the expand operation another time. Now, I'll return to AutoCAD and expand the segment again. This time, the order of the conductors is reversed, with the service cable being closest to the trench line. I'll again collapse and reset the segment. Okay, now let's explore further. Back in the rule editor, I'll create a new rule in the expand interval section. Note that the interval is a characteristic of segments. So in this configuration, I have two types of trench segments. I'll create a rule that uses the conditional number function, looking at the model name. If the model name is UG Pri Trench, a primary trench, if that's true, I'll set the expand interval to 3. Otherwise, I'll set it to 2. Note, this rule will override the interval setting in AUD options. Now I return to AutoCAD. The original design used a primary trench. I'll use AUD expand to expand everything in the trench. And as I did before, I'll use the dist command to look at the cable spacing. You can see here that the spacing is 3 feet because we have a primary trench. Okay, now I'll collapse the trench. I'll select the trench, and in Quick Info, I'll change the trench model from UG PRI trench to UG secondary trench. Now I'll again expand the trench and use the distance command to measure the interval, and it is indeed 2 feet now. To review, schematic behavior can be controlled by 5 different schematic rules as shown here. We explored using the expand interval rule, which lets you set the expand interval differently using different trench types. Remember that this overrides the setting in AUD options. We also explored creating an expand priority rule for conductors, setting the order of the conductors based on the conductor type. Sometimes it's helpful to take the basic AUD function and create a wrapper to simplify its use. Let me show you what that means. The AUD expand command requires that you select each segment that you want to expand. But suppose you frequently want to expand all the segments with a single command. Currently, this takes numerous mouse clicks. Is there a better way? On the screen, I have a more complete design with a number of segments containing different numbers of conductors. I'll illustrate the commands to expand everything first by typing these commands I want at the command line. First, I'll use the AUD select command. I'll enter AUD select. AUD will prompt me for the type of selection, and I'll choose query. Next, it wants a SQL statement that represents the query that will return all of the components that I want. So I'll type in select FID from EL segment. I'll explain more about this SQL statement in a moment. When I press enter, all of the segments in my design are selected. Now that all the segments are selected, I can run the AUD expand command. I'll indicate I only want to expand lines. And now, since the segments were already selected, it doesn't ask for me to select segments, and it simply wants the interval. I'll press enter, and my expand is done. Here's pretty much exactly what I typed to get this to happen. This is going to be important in just a second. The 2 commands shown here are the command sequence you want to implement within an expand all command. To make this work, you first need to create a Lisp routine that includes these 2 commands, and then you need to stick it on a ribbon so it's easy to access. Now, it's beyond the scope of this short video to fully explain how to program in Lisp, but for the sake of this video, I'll type vlisp at the command line to open the Lisp editor. And here's the actual program that runs the 2 commands. The command will be called DLC expand all, and it's pretty simple. Here's where it issues the command for the AUD select command. Here's where we include the query mode, and here's the SQL statement. And here's where we issue the AUD expand command. Here's where we indicate we're expanding lines, and the double quote represents when we press enter, meaning we want to accept the default interval. I'll select this list function and click up here to load it. Now I can switch back to AutoCAD. I'll collapse my conductors. Now I can type DLC expand all. You can see that this new command is now available, and when I press enter, the lines expand. Okay, that wasn't too bad. Now how do I add it to the ribbon? Again, it's beyond the scope of this video to explain everything about the AutoCAD CUI editor, but I'll open up a small custom tab I've created and drill down to the underlying support for the Expand All function. And here you can see the ribbon macro that will actually call the command. So back in AutoCAD, I have this new ribbon tab with a list of commands. And I can select Expand All, and there you go. Let's summarize what's needed to create Lisp wrappers. These wrappers use Lisp to execute AUD or AutoCAD commands, and they allow designers to reduce the number of keystrokes required for common command sequences. Indeed, these wrappers are best when you need to automate repeated functions. To create a wrapper, you first figure out the required command sequence, and what's essential is to figure out how to execute the commands entirely from the command line. Remember that your Lisp command doesn't include any mouse clicks. Once you know the keystroke sequence, you can create a Lisp routine to define a new AutoCAD command that executes the required keystrokes. And finally, use the AutoCAD CUI editor to put the command on an appropriate ribbon or on a toolbar. Now, how far can you take these custom Lisp functions? Well, there's really no limit. For the final part of this video, I want to show a more advanced function. Look at the custom menu that I just used. It provides access to two new wrapper commands, one for Expand All and another that I didn't explain in the video for Collapse All. It also provides access to the AUD out-of-the-box commands for basic expand, expand edit, and collapse. And it includes one more command, add bend at end. When I select this command, AUD prompts me to pick a point for a new vertex. I'm required to click near the end of an expanded cable. A second prompt then appears, asking me to specify a target point. This is the point where I want the cable to terminate. The command then puts a bend in the cable. Using this function makes it super easy to add bends to all the cables in short order. The command uses a predefined distance for the added vertex. This is clearly a more advanced function, but it gives you an idea of how the core power of the AUD schematic functionality can be extended to meet specific requirements at your utility and accelerate the design process for all your users. So, a final summary here. We've covered 4 ways to configure or customize AUD's Expand schematic capabilities. The first of these was pretty simple. It was using AUD options schematic configuration values. These are just general settings that control the schematic creation. Then we looked into schematic rules. This allows you to create utility-specific rules for ordering cables and conduits in the correct order when they're expanded, and for setting the intervals when they're expanded. Lisp commands were covered next, specifically Lisp command wrappers, which allow you to encapsulate commands and reduce keystrokes. And finally, we took a quick look at the option of creating a Lisp or an ARX custom power function that allows one to create utility-specific tools that can really accelerate design and layout.